Number 3, I'm going to take the partial of this function t with respect to k. So this is going to require the multivariable chain rule. So I just start this out by, I'm going to write down what I need to take the derivative. So I got to take the partial of t with respect to k. Well, the first thing I run into is the variable x. So I'm going to take the partial of t with respect to that variable first, and then the partial of that variable with respect to k. Add to that partial of t with respect to the next variable I see, which is y, and then multiply by the partial of y with respect to k. And then the next one I run into is z, so I'll take the partial of t with respect to z, and then the partial of z with respect to k. So I've got those 6 derivatives, partial derivatives to take. So the partial of t with respect to x is just going to be sine xy, y, z. Can't read the thing. Fix that a little bit. So sine y, z, because the derivative of the x is 1. And then I take the partial of x with respect to k. That's this one. It's just going to be 2k m n. So there's that one. Plus, now I take the partial of t with respect to y. Well, the y is inside that sign, so it's going to be, I have to take the derivative sign, which is cosine. There's an x out here. Derivative sign is cosine. Then I put my inside function yz back in there and take the partial of that with respect to y, which is going to give me z when I take that partial. That's that one. And now I take the partial of y with respect to k. That's right here's where the y is. So it's, again, a chain rule. It's the derivative is first one 0 because there's no k in it. But the derivative of natural log is the derivative of what's inside there with respect to k. So that's going to be n divided by what's inside there, which is kn. And then that will simplify to just give you 1 over k. And then the next one, we take the partial of t with respect to z. Well, that's sort of the same as what I just did with respect to y. So I'm still going to have x with a cosine, put my inside function of yz back in, and then multiply by the derivative of what's inside with respect to z, which just gives me a y. And now I have this one to take the derivative of with respect to k was e to the kmn. So it's the derivative of what's inside here times e to the kmn. So that's going to be mn e to the km n. It's kind of fitting in there, but anyway, that's just this function back. That's our chain rule from Cal 1 for the derivative of e. So just in case you can't see it there, that's that. And that's it. It says leave your answer in mixed form. It's just a matter of taking all those partials. So it's kind of partial practice. All right, this one, I want to evaluate this limit. That tells me it exists. You can see that if you put the 1 and -1 and 0 in, you're going to get 1 plus 1, 1 minus 1, and then 0 and 0. So you do get a 0 here in the denominator, and in the numerator you get 1 minus 1 and 0 again. You get 0 and 0 squared. So you do get a 0 over 0, which that's going to have to happen if I'm going to get a 0 in the denominator. I need 1 in the numerator to be able to cancel. And the way I'm going to do this is by factoring. If you look carefully up here in the top, that's a difference of squares, so I'll factor that and get limit x, y, z going to 1, -1, 0. Factoring the difference of squares, I get x plus y plus z, right? It's the a squared minus b squared will be a plus b. Here's my a plus b times the a, which is x plus y plus z, minus b, minus the z in this case. So that's my a plus b, a minus c, a minus b. Here I'm going to factor by grouping. I'll take an x out of these first two. Leaves me with an x plus y. Take a z out of the second two. Leaves me with an x plus y. And that's the part that's making a 0, right? There's 1 and -1 is what I was plugging in. So going one more step with my algebra here to finish off that. X, y, and z go into 1. Oops, there's an arrow there. 1, -1, 0. Here in the top, I now have x plus y plus 2z and x plus y. The z's canceling out there. And in the bottom, when I factor that x plus y out, I have left x plus z. And now I can just plug in my 1, -1, and 0 for my x, y, and z. Well, doing that here, I get 1 minus 1 plus 0. The top is going to go to 0. and the bottom is going to go to 1 plus 0. So the bottom's going to be 1, so that limit does turn out to be 0.